we are inside of this thing, so we have calculated flow path. Calculated flow path. This is calculated flow field. So this is going to be, where is this information located? It's inside the cache distances. Alright, so what color is the height map? It's the R channel. Alright, so let's just see what happens if we the R channel is the actual distance from the wall. So what we want is we don't want to subtract from anything. We want to add the inverse of it. So it's going to be like, 255 minus this value, because when it's black, it's distance of 0. So we're gonna go from 0 to 255, and then we're gonna multiply that by. Let's just have it multiply by 1 right now, and that'll be our magnitude. So we can play around with those magic numbers a little bit. So what we're doing is we're taking the heuristic in A star. This isn't even the right spot. I've got another spot where we actually compute another H, right? Yeah. The heuristic in A star basically determines how the search algorithm finds the path. So if we change the heuristic, it's going to try to find paths a little bit differently. It may not do what we want though, because we didn't actually build in the actual cost of the node. It's only the estimated cost of the node. The actual cost of the node is the distance traveled. This is the distance traveled from the source to the current node in the search space. The heuristic is just used to where to search next. So we're going to bias towards searching first in things that are a little bit farther away from walls. And the cool thing is we actually have our search algorithm. Well, we don't have it anymore, do we? Because we did have it on one of our textures. That distance map looks totally goddamn wrong. No, the movement in the water doesn't show yet. We haven't actually started on the water shader itself. I was like, why didn't that heuristic do anything? It's because our texture actually hadn't been updated, so... Yeah, that's not going to do much at all because those values are so small. Yeah, we'll get to it. It's going to take a while, Lucas, before everything really works for this. So what I'm doing here is I'm changing the value of the distance to shore that we kind of clamp to minimum. Alright, so this should give us a value, and it looks like, yeah, it's not going to be super amazing right through there, so our heuristic isn't going to do a whole hell of a lot for us. Yeah, see, it moved a little bit away from the shore. But it didn't move much. Let's give it a huge weight. Let's just slam that thing in there. And give it a much larger kick in the butt to get out of the way. Let's see. Yeah, we're really just going to have to multiply it out there. Let's do like a multiply it by 4 for the heuristic. Yeah, Lucas, if I was going to give you an estimate of when we'll actually have water that's moving around in any real semblance, like when we did all this stuff out here, the flow field is the most complicated piece. So we have a dynamic texture for the flow field. I mean, we've got the flow field, we've got the height map, we've got the shore map, and they've got like obstacles and the dynamic flow field stuff that we're going to update at runtime, which will just be kind of an overlay sort of thing for obstacles to like just have, if you like have something that's inside of the, or a rock that can move around, or a person or something, you know, we can have stuff kind of flow a little bit around it. But it's going to be like a real, you know, if the textures, it'll be interesting. It won't be, we'll have to figure it out. I'm not exactly sure how that'll work and how big of a texture I can even update at runtime. But it's going to be a hell of a lot simpler than what we're doing right now. So hopefully we'll be finished with all the information this week, and we'll actually have, like, you know, stuff basically moving around, but it's going to take a lot of time here, to be honest. Well, I kind of like that. The heuristic, messing with the heuristic did get us away from the center a little bit, which is good. And the shore repulsion is probably pushing all these things away from the shore. Alright, well, let's save this sort of stuff, and let's give it like 75 ticks and see what it can do with that. So let's crunch this out. Alright, so we'd have a whole bunch of water coming through here and out into the world. these particles couldn't go anywhere. And this stuff is coming out. These guys are moving fast over to here. Looks like they're just kind of getting stuck. That's fine. This will be like a turbulent area, but the main flow comes over here and out around. These things kind of just push against the rocks here and don't do anything. So anything that got in here would kind of just donk onto the rock. Well, I'm pretty satisfied with how this is going. That's what it would look like, kind of if you can imagine in your mind's eye, this would be water flowing up through here. So I think that's the information that we need. And I wonder if we would need anything else, like to make a waterfall like this, and we want the flow field. These particles are going to be, you know, the direction that they're want to go is this way. And these ones are going to go out here. And we're going to want like them going straight out because of these other. Because this is supposed to be kind of a bar. Like we could have like a certain number of, you know, spheres or something that we kind of model this with if we wanted to. And you could put like a couple drains on it and it would kind of model a waterfall. And we could have a radius on the drains and you just like throw 3 on there and, you know, a radius of like 40 or something, and those things will just drain pixels just fine. Well, I don't know. I think I'm pretty much, I'm feeling kind of done for today. Like I did 14 hours yesterday, and I think what, I've gotten about 4 today? I think that's pretty good. I don't want to, if I don't feel like doing a whole heck of a lot of work, I don't want to force myself to do it. And we're at a really good stopping point. We actually, the code is not trash, but it's not cleaned up. We'd have to do a bunch more cleanup, and you know, we need to like actually start supporting these objects in the real world that we can move around, like move the drains around. And then we need to actually use this information that we've collected with these particles and apply it to the world. But I think we've proven out our particle system actually can get the flow of the water, and it's got all the information we need, and it's going to be good enough. So we've solved, I think, the hardest problem with our water simulation, which is getting the water information. So we'll Like the refraction down there looks just so, it looks so trash. It's like this you know, very horrible. Like this is just the worst texture ever that I just like slapped in there. It looks like, you know, realistic water, and then boom, cartoon, like Breath of the Wild waterfall or something. It's like, oh yeah, that's not right. So I think I'm gonna call it here, and I'm probably gonna go over and troll Adam or something like that. So if you want any information about the game and all that, yeah, Breath of the Wild look pretty good. Yeah, I was saying it probably does. It's supposed to be all edgy and stuff. Yeah. So that's a link to the game, and if you want to check out Adam's channel, what was he doing? Just making some landscapes, just making some stuff. So Adam's over there working on stuff like 3D models that look like cones. So I think I'm gonna call it here. So thanks for sticking around, asking questions, and hope you guys have a good one. And I will most likely be back tomorrow and all that. Oh, he's making non-potato stalagmites and stalactites. That's cool. So I'll see you guys later. Thanks for sticking around, man.